Hey class! It's Friday, you guys ready? Show some excitement! By the way, don't forget, sampling's due tonight. Oh, is this bothering you, Cheryl? It is? We'll fix that, don't worry. No worries. Oh. Stay. Okay. That should be fine. So, are you ready to see something beautiful today? No? She did beautiful. Show some excitement at least. That's beautiful. Whatever. Okay, well today we're learning about a whole new class of production reagents. No, it's not carbon-carbon bonds. Carbon bonds are not even formed in this reaction. This is just has to do with complete reductions. Like, remember the Clemenson, the Wolff-Kishner, NeNa3, H2PDC? Refresh your memory a little bit. It's something like that. And they're called... No, stop that. They're called the hydride reductions. Cheryl? Nice catch.
Thank you. Oh yeah, I've heard of those. Aren't they like very useful for cognitive chemistry?
Yeah, they're very useful. This reduces about anything.
Wait a minute, anything? I'm so confused.
Well, maybe I can explain it in a better way. Do you remember the story about like Brownie logs and the chemical problem? Does that sound familiar? Do you watch even that show?
No, isn't that like a fairy tale with like Goldilocks and the porridge and stuff? What does that have to do with anything?
Yeah, it's something like that, but it's much better. Here, let me show you.
Grr, who goes there?
Hi, my name is Brownie Locks. I live in the chemical plant around the corner, and my company is trying to work to synthesize a drug, and they told me you three could help.
Oh, sweetie, we would love to help. What is it that you need?
No, Mama, we do not have time for this. We must go scavenge for carbonyls.
Please, I really want to help her. She seems really nice.
Okay.
Yeah, I don't mean to cause you any harm or take up any of your time. I just really need a reducing reagent.
Well, we'll certainly try to help you. We're a family of hydride reductions. It's our specialty.
Looks like you came to the right place.
It sure does.
Dr. Joe!
Yeah, Cheryl. Nice catch.
Thank you. That doesn't sound anything like the fairy tale I know. Where are the part about the one being just right and the chairs, you know?
Cheryl, you must be patient. It'll make sense in a minute. Do you know the 3 reducing reagents?
No.
No? Well, we have 3 reducing reagents. The first one is LiAlH4. Does this sound familiar?
Mm-mm.
Then I'll make it sound a little bit more familiar. Do you know Monster Bear? The big monster bear you see in the fairy tales and like cartoons and forest now? Well, LiAlH4 is Monster Bear. Why this thing is not writing well? Well, good throw. Alright, so Monster Bear. Did I spell bear right?
I think there's an A.
Nah, maybe you're right. What is this? Who uses these drags anymore? Well, maybe it's Dr. Fantini. Anyway. So it's Monster Bear. Do you know the second reducing reagent, NaBH4? No? Well, this is Mama Bear. Like, this is a little bit aggressive than Monster Bear. Mama Bear. And do you know what this little kid is called?
No.
This is Baby Bear. Baby Bear is like so cute, so adorable, so little.
Okay, I still don't really get what this has to do with anything.
Well,
Why is it important?
well, let's go back to the story and see.
So, Brownie Locks, what kind of reduction are you looking for?
I'm looking for something that can reduce...
Just about anything? That's me. I'm Monster Bear, and I'm lithium aluminum hydride.
What kind of reducer are you?
Let me show you. As I mentioned before, I'm lithium aluminum hydride, LiAlH4. So we have our hydride reagent, and this is a nucleophilic hydrogen. It goes in and attacks electrophilic carbon, kicking these bonds up to the oxygen, giving us our tetrahedral intermediate right here. And the electrons from the oxygen kick back down, and this built-in leaving group leaves, giving us our aldehyde intermediate right here. The hydrogen in the hydride reagent again goes and attacks electrophilic carbon, kicking the electrons up to the oxygen, forming us our intermediate over here. The oxygens go and attacks the ALH3, giving us our product right here. And now we have a simple acid-base reaction where water protonates and we get our primary alcohol product.
So what kind of things can you reduce?
I can reduce just about anything, including carboxylic acid derivatives, amides, and epoxides.
Wow, that is impressive, but I think I need to be a little more selective and careful in this process. I mean, it is a really important drug.
What about me?
What kind of reducer are you?
I'm Baby Bear. I'm Dipol H.
What kind of things can you reduce?
I'm picky. I can only reduce acid chlorides and esters to aldehydes. When I reduce an acid chloride, I only get the aldehyde, and when I reduce an ester, I get the aldehyde and the alcohol.
Wow, that is a really impressive group of reactions, but I was really hoping to find something that would reduce an aldehyde to an alcohol, but I guess I'll just have to keep looking.
Wait, did you say reduce an aldehyde? That's what I can do. I'm Mama Bear, and I'm NaBH4. In my reaction, first, the nucleophilic hydrogen of NaBH4 attacks the electrophilic carbon of an aldehyde molecule, while the oxygen attacks the boron. This gives us our first intermediate, where NaBH3 is attached to the oxygen. Another nucleophilic hydrogen attacks another molecule of aldehyde at the electrophilic position, while the oxygen again attacks the boron atom. This happens 3 more times and gives us our final intermediate, where boron is attached to 3 esters. Methanol then comes in, and a hydrogen is drawn by this bond, and the oxygen attacks the boron, giving us our final primary alcohol product. I also can reduce ketones to secondary alcohols.
That is just right. I'm so glad I came to you guys. Now my drug company can selectively and effectively synthesize this new drug.
You're welcome, Brownie Locks. We're happy to help you.
If you don't mind me asking, what kind of drug are you trying to make?
Well, I'm not really supposed to tell you because it's top secret, but since Mama Bear has been so helpful in the process, I guess I can give you a hint. It's going to increase the bee to honey ratio tenfold.
Now, do these reactions make sense?
Yeah, and the gravity of their selectivity is even more apparent to me now. Thank you for explaining such a complex process in organic chemistry, using such a friendly and relatable story. I don't think I will ever forget the story about Brownie Locks and the chemical problems.
Great, I'm so glad. And I'm glad we got through this so quickly. I now have 3 hours to do my CrossFit and go accept my Nobel Prize. Well, I need another marker. Let me get it.
Wow, that is a really impressive
Molecule, atom. Oh my god.
Monster Bear? Well, Monster Bear is the one like you see in the cartoons, forest, and all these kind of shit.
Aldehyde.